Sunday, Manuel Ezekiel. This is the first slide. It speaks a brief way about me as I'm the speaker of this presentation. Let's proceed to the next slide, which emphasizes on evolution of computers. We shall be talking about evolution of computers, which refers to the historical developments through which computers and technology have passed the time they started to exist in ancient forms to their current state. Computer evolution since 1946 has been categorized into 5 generations. Each generation had a major characteristic development, distinct characteristics in terms of physical setup, technology, software, setbacks, the computers. This slide here majorly portrays a pictorial view of the generations of computers, starting from the first generation to the second generation, the third generation, to the fourth generation, then to the present state. So we shall proceed to the next slide where we shall dive into the first generation, explaining some few details about it. So the first generation computers majorly, was between 1946 to 1959. The main invention there was vacuum tubes, which mainly talked about the computers used vacuum tubes. Then the vacuum tubes was an extremely important step in the advancement of computers. Then, basing on the physical setup of the first generation computers, physically, first generation computers were very large. Machines with hundreds of thousands of vacuum tubes were built, taking up space of several planes. Big. They weighed about 30 tons. Then this slide here talks about the technology part of the first generation computers. They used punched cards and paper tapes for input. They used magnetic drums. They had memory size of approximately 2 kilobytes of RAM. They used binary number system. Speed was about 10,000 instructions per second. Then the software version of the first generation computers included, they used machine language, the lowest level programming language understood by computers. Then proceeding to the next, setbacks, disadvantages. They broke down frequently, needed very many people to operate due to their huge size. High level of training was required. They produced a lot of heat. They consumed a lot of power. They produced a lot of noise. They had limited primary memory, so they were very slow. They were very expensive to buy, set up and maintain. They were not portable. Then proceed to examples. There was electronic numerical integrator and calculator. There was debug, electronic discrete variable automatic computer. It was built for the US Army Ballistic Research Laboratory. Then the UNIVAC was the first general purpose electronic digital computer designed for commercial use. Then proceeding the second generation computers, transistors. The hallmark, a transistor is a semiconductor device used to amplify and switch electronic signals. Yeah, that's a brief explanation of transistor because it was the main invention during that period. Then the physical setup of second generation computers which happened between 1959 to 1965. The computers reduced in size as compared to first generation computers. A typical second generation computer contained 10,000 transistors, hand soldered, connected by wires. The technology bit of the second generation computers, they still use punched cards and printouts for output. Memory size expanded to approximately 32 kilobytes. The computers reduced in processing speed and reliability. That is approximately 30,000 instructions per second. This has consumed less power as compared to vacuum tubes. We removed from a magnetic drum to magnetic core technology. Then the software part of it is that they used assembly and high-level programming languages such as Fortran, which allowed programmers to specify instructions in words. The setbacks, they produced less noise. Their cost was very expensive. High addition is required. Examples of second generation computers: IBM 305 Pramac 1956 was the first commercial computer that used a moving head hard disk drive, and the IBM 1401 was a variable word length decimal computer that was announced by IBM. The CDC 6600 was a mainframe computer for data corporation. Then the third generation between 1965 and 1971, integrated circuits. The major technological advancement was an integrated circuit was just a combination of thousands of transistors and tiny wires onto a small chip made of semiconductor materials such as silicon. And the physical setup of third generation computers was the computers extremely reduced in size due to fabrication various circuits. The computer could now fit onto a desk and the monitor because the largest visible part of it. And proceeding the technological part of it, the keyboards and monitors replaced punched cards for input and output. Magnetic hard disks were developed for storage purposes. Memory size expanded to approximately 2 megabytes of RAM. The computers became more reliable because of elimination of soldered joints and need for fewer interconnections. Speed increased to 5 million instructions per second. Integrated circuits consumed lower electric power. Then the software version of it was simple programming languages like BASIC were introduced. Multitasking was now possible. The setbacks was highly sophisticated technology required for manufacture of IC chips. They required air conditioning in many cases due to the heat produced. If any component in IC fails, the whole IC has to be replaced by a new one. Operations were at low voltage because ICs function at fairly low voltage. Examples were the PDB-8 was the first commercially successful mini computer, and the HP 2115, which was made by Hewlett Packard, first mini computers such as the IBM 360 series. Then one of the great inventions during the third generation computers was the ARPANET. Another very good development that came up in this generation was the Advanced Research Projects Agency Network, the world's first operational packet switching network, which was majorly developed by a team in the United States Department of Defense. Then proceeding to the fourth generation computers, the microprocessors are the very large scale integration whereby it's the process of integrated circuits by combining thousands of transistors into a single chip. A mini processor brought the fourth generation of computers as thousands of integrated circuits rebuilt on a single silicon chip. The invention of the microprocessor was made by a team at Intel Corporation. And the physical setup was kept on reducing generation to generation the development of microchips. And proceeding to the technological part of it, the fourth generation computers saw the development of the mouse, the handheld input device. The fourth generation computers were more powerful. They could be linked together to form networks. A vast range of storage memory media used such as floppy disks. Then memory size progressively expanded. The computers became very reliable. They don't need air conditioning because they were inbuilt cooling mechanisms. Let's have a break, then we shall come and proceed to the software version. Thank you. Yes, welcome back from the break. We were still talking about the software part of it, version. Operating system based on graphical user interface were developed. Graphical user interface is a user interface in which images such as icons and buttons are used to issue commands. Then it also had setbacks whereby highly sophisticated technology for the manufacture of large scale integration chips, then operations at low voltages as microprocessors, function at fairly low voltage. Then proceeding to examples of both generation computers. The Xerox Alto 1973 was the first computer to use GUI. Then the IBM 5100 portable computer that appeared in September 1975. Then the Apple Macintosh in 1984. Then proceeding to fifth generation computers, where between 1980 to the present state, artificial intelligence and robotics was the main invention, whereby artificial intelligence is the ability of machines to have human capabilities such as the five senses: see, hear, feel, taste, smell. The physical setup of the fifth generation, the physical size of computers in this generation can be customized to any shape of interest, be it as small as a pen. Then the goal of fifth generation computer is to develop devices that respond to natural language input. Then the technological part of it is that there is use of coordinated parallel processing where computers have many microprocessors by being used. We shall see the development of many gadgets like remote control, secondary storage hard disk drives. RAM will continue to increase to 8 GB, 26 GB, 32 GB, 64 GB. The computers became 99% reliable. We're talking about the software version of the fifth generation computers. Fifth generation programming languages will be used. There will be a wide variety of computer operating systems. Then the setbacks of generation computers was computer obsession and addiction is serious, spoiling the writing and thinking abilities of human beings. Then robotics. In the fifth generation computers, fifth generation, it will result into unemployment as machines take on the jobs people could do. Then examples of fifth generation computers. The Tosi Ping Pong playing robot is a humanoid robot designed to play table tennis against a human. Then the hospital robots, which is also a great example. Then we shall also talk about the evolution of the Intel x86 AR and ARM architecture. The Intel x86 and ARM architecture are two of the most influential and widely used processor architectures in the world of computing. Each architecture has a unique history, design philosophy, and set of instructions. This overview will delve into the evolution of the Intel x86 architecture, known for its versatility, personal computers and servers, as well as the ARM architecture celebrated for its power, efficiency, and ambiguity, mobile devices, and embedded systems. Understanding these architectures is essential to grasp the diverse landscape of modern computing. Let's dive into the Intel x86. 8086, that's around 1978. The Intel 8086 was the first microprocessor in the x86 family. It featured a 16-bit architecture and laid the foundation for the x86 architecture. Then 80,386, 1985. The 80,386, or simply 386, introduced 32-bit architecture and brought multitasking capabilities. It was a significant step forward in x86 evolution. Then we proceed to 1993, that's the Pentium. The Intel Pentium processors became iconic in the 1990s and improved performances with each iteration. Then we're talking about the continuation of the Intel x86. 64-bit transition, that's in 2003. The introduction of the Intel Titanium and AMD Athlon 64. The x86 architecture transitioned to 64-bit, offering better memory addressing and performance. Multi-core era, mid-2000s, Intel began integrating multiple cores to their processors, hence parallel processing power. Improvements ongoing. Intel has continued to improve its x86 architecture with microarchitectures like Halelem, Sandy Bridge, and beyond. To proceed ahead, we shall talk about the ARM architecture, which is the Acorn RISC machine in 1985. The ARM architecture was initially developed by Acorn Computers as a RISC-reduced instruction set computer architecture. It aimed at providing efficient computing low-power devices. ARM Holdings, ARM spun as a separate company, ARM Holdings, which licenses its technology to other companies for customization. Then the mobile dominancy, that's in the late 1990s to the 2000s, ARM produces processors became dominant in the mobile industry due to their energy efficiency. Companies like Qualcomm, Apple, and Samsung adopted the ARM architecture for their mobile chips. We proceed to the next part. The architectural expansions in 2000, the late 2000s to 2010, ARM expanded its architecture to cater to various markets, including servers, that's in the ARM 8A, then embedded systems, ARM in 7M, and IoT devices. 64-bit ARM in 2000, ARM introduced its 64-bit architecture, ARM 8A, to compete with x86 in the server and high-performance computing markets. Then diverse ecosystems ongoing. ARM architecture powers a wide range of diverse devices from smartphones and tablets, servers, and IoT devices due to its energy efficiency and scalability. In conclusion, both architectures have seen continuous development to adapt to changing technology trends and user demands, making them vital players in the computing industry. My name is Sunday. Please comment on the video, then like the video, and also subscribe to the video so that you don't miss out other useful contents that will be put there. In case you have any suggestions for any other video, please comment there, see your comments, and I'll respond. Thank you very much for this time, for sparing to watch my video. Till we meet.